Hi guys, good evening to all. So let us discuss some basic concepts in physics. So today we are going to discuss about units and dimensions. So in unit and dimensions, what we are going to see? Dimension. What do you mean by dimension? Dimension means what we measure. What do you mean by unit? What we measure with. What we measure with. That means you are using which type of standard of measurement to mention it. That is the meaning of what we measure with. Here, what is the need for measurement in physics? To understand any phenomenon in physics, we have to perform experiment. Experiments require measurements, and we measure several physical properties like length, mass, time, temperature, pressure, etc. Experimental verification of laws and theories also needs measurement of physical properties. So, what do you mean by physical quantity? A physical property that can be measured and described by a number, that means it should be well defined, is called physical quantity. For example, mass of a person is 65 kg. So, here you have measured how much mass. We are mentioning how much kg, 65 kg. So, with the unit we are mentioning. Length of a table is 3 meter. Area of hall is 100 meter square. Temperature of a room is 300 Kelvin. So, here we are giving correct measurement described by a number. So, it is a mass, length, area, temperature, they are all called physical quantities. Physical quantities can be divided into two types. One is fundamental quantities. The physical quantities which do not depend on any other physical quantities for their measurements are known as fundamental quantities. Example, mass, time, length, temperature. Another one is derived physical quantities. The physical quantities which depend on one or more fundamental quantities for their measurements are known as derived quantities. For example, area, speed, volume, force are called derived quantities. So, what do you mean by unit? The standard used for measurement of a physical quantity is called a unit. So, otherwise, we can also define it is a standard of measurement. For example, meter, foot, inch, they are all the units using for length. Kilogram, pound, we are using for mass. Second, minute, hour, we are using for time. Fahrenheit, Kelvin, we are using for temperature. So, what are the characteristics of units? Unit should be well defined. It should have suitable size. Unit should be reproducible. They should be invariable, indestructible, internationally acceptable. These are all some characteristics of units. There are three systems of units. So in ancient days, we have followed CGS system of units. This system was introduced in France. It is also known as Gaussian system of units. It is based on centimeter. That means we are measuring length in centimeter, mass in gram, time in second. So we are calling it is CGS. Next one is MKS system of units. The system was also introduced in France. It is also known as French system of units. It is based on meter. That means length is measured in meter, mass is measured in kilogram, time is measured in second. So they are called the MKS system of units. Next one is FPS system of units. This system was introduced in Britain. It is also known as British System of Units. It is based on foot. Length is measured in foot, mass is measured in pound, time is measured in second. So we are calling FPS system. So among all the three systems, we modified MKS system. Modified form of MKS system is called SI system. That means International System of Units is shortly called as SI system. In 1971, General Conference on Weight and Measures held its meeting and decided a system of units for international usage. This system is called International System of Units and abbreviated as SI from its French name. The SI unit consists of 7 fundamental units and 2 supplementary units. You know what are all the 7 fundamental units? Length. SI system for length is meter, symbol M. Mass. SI unit is kilogram, symbol kg. Time. SI unit is second, symbol S. Temperature. SI unit is Kelvin, symbol K. Electric current. SI unit is ampere, symbol capital A. Luminous intensity. SI unit is candela, symbol CD. Amount of substance. SI unit is mole, MOL simply we are writing. And there are 2 supplementary units are there. First one is radian. It is also measured plane angle. It is 2-dimensional. So here in a circle, if your body travels from A to B, so how much angle it creates at the center of the circle, that is called theta. It is mentioned by radian. So theta is equal to 1 radian. Suppose if it covers half of the circle, pi radian is equal to 180 degree. So likewise we are measuring. Here second one is radian. It is used to measure solid angle. So the vertex of the cone, it is called as solid angle. So here the symbol mentions 1 radian. Next one is rules for writing SI units. Some of the rules we will discuss here. First one is full name of unit always starts with small letter even if named after a person. Yes. For example, for force we are using Newton. It should be written like this. You should not use the capital N. The same way for current you are using ampere. You should not put capital A while writing the name of the unit. Coulomb, you should use all the letters are small. You should not use first letter is capital. It should not be like that. Second rule, symbol for unit named after a scientist should be in capital letter. Yes. Suppose for Newton you can use the symbol capital N. No problem. It is correct. For ampere you can use the symbol A. For Kelvin you can use the symbol capital K. For Coulomb you can use C. Symbol you can use capital letter. Next one is symbols for all other units are written in small letters. For example, for meter, small m you are mentioning, kilogram, kg, second, small s, candela for CD. So you are using small letters. Next one space is left between the last digit of the numeral and the symbol of unit. So while you are writing the number and the unit, one space should be left here. It should not be write continuously like this. So it is not, they are all wrong. It is right. It is right. The units do not have plural forms. For example, if you write 6, you should write meter, not meters. It is wrong. 14 kg, not kilograms. 20 second, not 20 seconds. 18 Kelvin, you should not write 18 kelvins. They are all wrong method. It is right method. Full stop should not be used after the units. That means you should not use full stop. 7 meter, 12 Newton, 25 kg. but you should not put full stop here. Here you observe here a full stop is there. You should not use the full stop. No space is used between the symbols for units. That means, for example, joule second you are writing means you should not leave a symbol between the joule and second. Newton meter you should not use the symbol. Volt and ampere, VA. Here some space is there. You should not use the space while writing the units. It is wrong method. These are all wrong. So this tabular column mentions you what is the prefixes and suffixes. For example, 10 power 1 it is called deca, 10 square hectare, 10 power 3 kilo, 10 power 6 mega, 10 power 9 giga, 10 power 12 tera, 10 power 15 peta. It goes like this. For example, 10 power minus 1 deci, minus 2 centi, minus 3 milli, 10 power minus 6 micro, 10 power minus 9 nano. These are all prefixes and multiples and submultiples. Multiple means you are getting plus number, submultiple means you are getting in the power minus number. So what are all the symbols here? Here you see how we are using the prefixes. For example, 3 millimeter. 3 millimeter can be written as 3 milli m, small m, a, ampere. 3 into 10 power minus 3 ampere. 3 MA can be written as 3 into milli means 10 power minus 3 ampere. So 3 into 10 power minus 3 ampere can be written as 3 MA. 5 microvolt, micro symbol mu, volt V. So 5 into 10 power minus 6 volt can be written as 5 microvolt. 8 into 10 power minus 9 second, 8 nanosecond, because 10 power minus means nano. So likewise, how we are using the prefixes, how we are using the multiples and submultiples. This is the method of using the multiples and submultiples, some of the uses. See, what do you mean by dimension? The powers of fundamental quantities in a derived quantity are called dimensions of that quantity. That means powers of fundamental quantities in a derived quantity. If you are writing a derived quantity, what are the powers? You are using the fundamental quantities only, and the fundamental quantities are raised to represent a derived unit. So they are called dimension. Here you see what is the symbol for length L, mass dimension symbol M, time dimension symbol T, temperature Kelvin, current ampere, amount of substance. Sometimes here they have given N, sometimes mole they will simply note it as mole only. Luminous intensity I, it is not J actually. Some books they are using I. Here it is mentioned J. Some books they are using I. Here you see how to write a dimensional formula and what is mean by dimension and dimensional formula. You know, for density, what is the general formula? Mass by volume. Mass by volume means length into breadth into height. That means breadth and height also they are considered as length only. That means length into length into length. So mass means dimensional symbol capital M. Length, breadth, height, for all these three items we are using the dimensional symbol L only. So M by L into L into L. So M by L cubed. Suppose if L cubed comes in the numerator, what happens? M L power minus 3. Here, if you take the whole formula m L power minus 3, the m L power minus 3 is called dimensional formula for density. Suppose what is the dimension? M, what is the number in the power? What is the power of m? The dimension of density means 1 in mass. That means m power 1 and minus 3 in length. So L power minus 3. So 1 in mass minus 3 in length. So what are the numbers in the power of dimensional symbols? That is called dimension. The numbers may represent dimensions. The whole formula represents dimensional formula. So likewise, we can derive any number of formula, any number of dimensional formula for any other physical quantities. So it is only example. What are the uses of dimension? Dimensional formula or dimensional analysis is used to check the correctness of an equation. dimensional analysis is used to convert one system of unit into another system of unit to convert units. And the dimensional analysis is used to derive a relation between different physical quantities. That means to derive a formula we are using dimension method. Here, how to check the correctness of an equation. Here you see the equation del x equal to v1t plus half a t square. That means it is nothing but the equation similar to the equation you see here, s is equal to ut plus half a t square. The same equation similar to this equation only they have given like this. So s means displacement. They have written del x means displacement. U means velocity, t means time. The same way half a t square. So in the half a t square you take a t square, acceleration a time t square. So what happens here, if you apply the dimensional symbol for both sides, displacement L, velocity into time means, velocity means displacement by time, that means length by time into time, so you are getting L only. Acceleration means length by time square into time, so you are getting L. So in all the terms you are getting L only. The dimensions of the terms on both sides of the equation is same, so it is correct. So next one. So the next use of dimensional analysis is to convert units. So let us how to convert Newton. SI unit of force is Newton into dynes. How to convert? So you know the dimensional formula for force. You write the dimensional formula. 1 Newton is equal to, you just apply the values. Length means 1 meter, mass means 1 kg, time means 1 second square. In the dyne also you use centimeter, gram, second square. So if you divide both the items, you are getting like this. That means 10 power 5 dyne. That means 1 Newton is equal to 10 power 5 dynes. So to derive a formula, to derive relation between different physical quantities, this dimensional method is used. You know, to derive t is equal to 2 pi root of L by g. That means 2 pi means constant. So square root of L by g. How to derive this? So t is proportional to L power a, g power b. You are taking like this. So if you eliminate the proportionality symbol, you will get equal symbol followed by a constant L power a, g power b. So you apply the dimensional formula for both the sides. So you are solving the powers, what you are getting. So what is the value of A, what is the value of B? If you substitute the A and B, you are getting like this. So you observe this, simply you are substituting the values and deriving the values. So errors in measurement. Difference between the actual value of a quantity and the value obtained by a measurement is called an error. That means error means actual value minus measured value. It will give you the error. What are the types of errors? One is systematic errors, another one is gross errors, third one is random errors. Systematic errors. These errors are arise due to flaws in experimental system. Flaws means drawbacks. The system involves observer, measuring instrument and the environment. These errors are eliminated by detecting the source of the error. What are the types of systematic errors? Personal errors, instrumental errors, environmental errors. So, what do you mean by personal errors? These errors are arise due to faulty procedures adopted by the person making measurement. It is called parallax error. Suppose you have to see the reading straight. If you are seeing from left side for right side, you will observe the wrong reading. It is called parallax error. It is example for personal error. Next one is instrumental errors. These errors are arise due to faulty construction of instruments. So while constructing the instrument, here you see one value is 0.1. The indicator shows 0.1. Here you observe below the 0 line the needle is there. That means it will not show correct value. So it will show extra one value, it will show extra, it will show the wrong value. That means, for example, if it is 2, but the value should be 2.1 or 2.2. So it is behind the 0. So it will also show wrong errors. So it is called instrumental errors. It should be straight correctly, it should be pointed in the 0. That is called a 0 error. Next one is environmental errors. These errors are caused by external conditions like pressure, temperature, magnetic field, wind, etc. Following are the steps that one must follow in order to eliminate the environmental errors. Try to maintain the temperature and humidity of the laboratory constant by making some arrangements. Ensure that there should not be any external magnetic or electric field around the instrument. You can avoid the environmental errors if you take these precautions. Another one is gross errors. These errors are caused by mistake in using instruments, recording data and calculating results. For example, a person may read a pressure gauge indicating 1.01 Pascal as 1.10. By mistake, a person makes use of an ordinary electronic scale having poor sensitivity to measure very low masses. So these examples will come under gross errors. Careful reading and recording of the data can reduce the gross errors to a great extent. Last one is random errors. These errors are due to unknown causes and are sometimes termed as chance errors. Due to unknown causes, they cannot be eliminated. They can only be reduced and the error can be estimated by using some statistical operations. So thank you very much. Now we come to the end of the session.